this is Ms. DB. In this video we are going to look at absolute value equations and inequalities. So we've looked at absolute values before, or you have before, and the absolute value of a number is always positive. That's because it is the distance from 0 on the number line, and distance is always positive. So just as a review, each of these would be a positive. If you take the absolute value of 4, the answer is 4. The absolute value of negative 4 is 4. The absolute value of negative 56 is a positive 56. The absolute value of 101 is 101. So we're not taking the opposite, we're taking the positive. If you have a problem with absolute value that you have to simplify, here's the steps. Simplify within the absolute value bars first, then take the absolute value of that part and then simplify. So for example, number 5, 16 minus 98, and these bars here mean the absolute value of that. So you first figure out what 16 minus 98 is negative 82. So you keep the absolute value bars, right? Absolute value of negative 82, and that is equal to, then you take the absolute value and you would get the positive 82. So you don't take the absolute value before you simplify what is inside the bars. Now in 11, this one is a little different because there is nothing to do inside of the absolute value bars. So you just go ahead and take the absolute value of negative 4, and then you simplify 11 minus 4 and get your answer. The absolute value bars for typing are on your keyboard right above the Enter key. So if I wanted to type the absolute value of 8, I would type Shift. I'd hold the Shift key down and then hit that backspace key above the Enter, and it gives you that nice straight line. And then you can type your number and then the other absolute value bar on the other side of it. So that's how you simplify absolute value expressions. Now the next section we're going to look more at equations, solving absolute value equations. So in an absolute value equation, you are going to think about both of the options that you could have when you take the absolute value of a number. So the absolute value of negative 5 is 5. The absolute value of 5 is 5. So if I had written the absolute value of x equals 5, we know that there's two answers. It could have been, x could have been negative 5, x could have been positive 5. So we are going to do this for our problems. We are going to write two cases of our expression, of our equation. All right, let's look at an example. Absolute value of x plus 5 equals 25. So sometimes we have to isolate the absolute value expression to get it by itself, but we only have the absolute value on the left side, so that part is done. Or we don't have to do that part. So what we do need to do is the next part, which says to write two cases. So one case is the positive, if x plus 5 is equal to a positive number. So we write x plus 5 is equal to 25. That's one equation, and then we'll simplify that later. And the other case is if we have a negative number inside of the absolute value sign, so that would mean x plus 5 would be equal to negative 25. And then we solve both equations. So x plus 5 equals 25, I would subtract 5 from both sides and get x equals 20. And over here I would subtract 5 from both sides. Negative 25 minus 5 is x equals 30. So our answer is both of these. You write down both of them with and in between. They're both solutions. So when you are simplifying absolute value, like if you have 3 times the absolute value of 2x plus 1, the first step is to use inverse operations to isolate the absolute value expression. You would not multiply 3 through the absolute value stuff. Can't do that. So instead we're going to isolate this. We're going to get it by itself by dividing both sides by 3. Then we cancel the 3 out, and now we have the absolute value all by itself on the left side. So the absolute value of 2x plus 1 equals 2. And then you write your two cases and you solve both equations, and you'll get two different answers. And those are your two solutions for the for the equation. There's a Desmos calculator you can use to check your work on the rest of the problems if you want to. Alright, so let's look at number 9. It started. So one of your equations is you just drop the absolute value and say it's equal to 10, just like it's written. And the other one, you would put the exact same thing except you write negative 10 here. So you solve both of these and you get 2 answers, and those are your 2 answers. Now in 10, your first step is to isolate the absolute value expression first because it's 2 times that. So you would have to divide both sides by 2. And when you divide that by 2, you'll get the absolute value of x plus 2 is equal to 3. And then you write your 2 equations. So one of your equations is exactly what it says except you drop the absolute value. And the other equation is you put it equal to a negative 3. And then you solve both of them and you get your 2 answers. So every one of these you're going to have 2 equations to solve. Let's look at number 12. Number 12 says 5 times the absolute value of x minus 4 equals negative 30. So I have to isolate my absolute value expression first. So I divide both sides by 5. And that would give me the absolute value of x minus 4 is equal to negative 30 divided by 5 is negative 6. So let's think about that a minute. The absolute value of something, x minus 4, is equal to a negative number. Let's go back and look at what absolute value means. Absolute value is distance from 0 on a number line, and it's always equal to a positive number. So how can I have the absolute value of x minus 4 equal to a negative number? Whatever I put in here for x, how can I possibly get a negative number once I take the absolute value sign? Let's try some numbers. What if I put 10 in there? 10 minus 4. Well, that gives me 6, and the absolute value of 6 is 6. How can 6 be equal to negative 6? It can't be. If you get the absolute value, once you isolate it and get the absolute value equal to a negative number, there's no number for x that would make this true. It can't be, because the absolute value always makes it positive. So there's no solution for number 12. So watch that and see if that happens on any other problem. Alright, the next problems are absolute value inequalities. So there's 2 different types. There's those that have a less than, or it might be a less than or equal to. So we're going to look at a few of these first. And then there's absolute values that involve a greater than. There's a little bit different process when it's a greater than versus a less than. So first we're going to look at the example for less than. The inequality absolute value of x, I'm looking here, is less than a. Ask, what values of x have an absolute value less than a? So the solutions are numbers between negative a and a. So let's look at this. If, as an example, absolute value of x is less than 5. So here's our number line. Here's positive 5. Here's negative 5. This is very similar to the problem that we looked at earlier, right here. Any of these numbers between 5 and negative 5 would make this expression true, because the absolute value of 1 is 1, and that's less than 5. The absolute value of negative 1 is 1, and that's less than 5. The absolute value of negative 4 is less than 5, because that's 4 is less than 5. So when you have a less than, you're going to write this as a compound inequality, and that will be your solution. If you're asked to graph a solution, it would look like, that, except this would be negative 5 and 5. So here's another example. The absolute value of x plus 3 is less than 12. Well, the first thing you have to do is isolate your absolute value, so you subtract 3 from both sides, and you get the absolute value of x is less than 9. Now we think to ourselves, what does that mean? It means that x could be between negative 9 and 9. And you can write it like this, or you can write it as two separate inequalities, x is greater than or equal to -9 and x is less than 9. And then if you're asked to graph it, you would put open circles at -9 and 9 and then the line in between them. Let's look at another one. This time we'll have to do a little bit more work. The absolute value of x plus 4 is less than or equal to 2. So I'm going to write my two inequalities here, just like when we did for compound inequalities. X plus 4 is less than or equal to 2. I write one of them exactly the same. The other one, you put a negative in for the right side, and you switch the less than to a greater than. So I switch this to the greater than, and I put a negative here. The reason is I'm looking for when this part inside was a negative. So when does this happen? And if I have a negative here, I could put a -1 here. I could divide both sides by a -1, and when I divide by a negative, I have to switch this to a greater than. So now we get x plus 4 is greater than or equal to -2. So that's the reason why this works. And then you solve both of these inequalities and you get your solutions, and then you would graph your solutions if you're told to graph them. So in these problems, you don't have to graph. You can do that for extra credit if you want. All right, so these examples of lesson, let's do 15. So the first inequality, you just write it exactly the same as it is. Done. Solve it, finish it, you'll figure it out. The other one is when this is a negative inside. So because if I had that, I'd have to divide by a negative to get this solved. I write x plus 7 is greater than, switch the direction, and then put the -3 here. Now solve both of these. So this is x is less than -4. And this is x is greater than -10. Now put the smaller one first, so -10 is less than x is less than -4, to write it as a combined compound inequality. And if you were to graph it, for extra credit, you would have an open circle at -10 and an open circle at -4, and you would want all the values in between them. So this is a very similar lesson to the compound inequalities once you rewrite them. A greater than absolute value is very similar to the or type of inequality. So the way that we do these problems is one of them again is exactly the same. The other one, we switch the direction and we put the negative. So looking at letter B example here, they subtracted 5 from both sides to get the simpler inequality in the absolute value by itself on the left. Then one of them, x minus 8 is greater than or equal to 6, gets written exactly the same. The other one, you switch the direction of the inequality and you change it to a negative. And then you solve both inequalities and solve. So the steps are the same as for the less than, except that the less than was an and the greater than is an or. And the reason that this is an or is because you'll see the solutions point away from each other. All right, how about number 19? Number 19 says the absolute value of 7x is greater than or equal to 21. So we don't have to isolate the absolute value, it's already by itself. So one of them you just write exactly the same and solve that. And the other one, you would change this to a less than or equal, and you change the 21 to a -21. So if we solve each of these, x is greater than or equal to 3, or x is less than or equal to -3. So we won't combine this because this is an or. Let's look at it on a number line. X is less than or equal to -3 would be a solid dot at -3 and an arrow pointing to the left. X is greater than or equal to 3 would be a solid dot at 3 and an arrow to the right. So you would just put an or between these two, and the graph, if you're going to graph, would look like that.